So we have discussed in our first module chemical energy, fossil fuels, knocking, and various sources, right, of energy. So one among that was solar energy, so renewable source. So we can also store energy in batteries. So what are batteries? That's a general question. So today let us see what is a battery, different classification of batteries, what those mean, and a small animation how a battery works in today's discussion. So battery in general, it's a device which consists of two or more galvanic cells, which is either connected either in series or parallel. So any device, so like electrochemical cell, which either is connected in series, if two or more electrochemical cells is either disconnected in series or parallel, it forms a battery. The main purpose of battery is to supply the necessary current. So I have example for battery. Your lithium ion battery is used in the mobiles. Your lead acid battery is used in your automobiles. Automobile may be your two-wheeler, your four-wheeler, your six-wheeler, maybe car or your bus, lorry, etc. Isn't it? So battery is basically a device which consists of two or more electrochemical cells, that is your galvanic cells either connected in series or parallel to provide necessary current. So batteries are classified mainly into three types. They are primary battery, secondary battery, and your reserve batteries. Let us discuss these primary batteries and secondary batteries and reserve batteries. What are these one by one? What are primary batteries? All non-rechargeable batteries are called as primary batteries. So this diagram clearly explains the electrochemical cells you have divided into two. One is a battery and a cell. So battery, primary, secondary. Cell, we have dry cell, wet cell, reserve cell, and fuel cell. So we're concentrating only about batteries here. So batteries, primary and secondary. What is a primary battery? All use and throw batteries are primary battery. So the shell which you use in your wall clock, so it's used and it cannot be recharged. The cell which you use in your watches, so those are primary batteries. So here the electrical energy is obtained at the expense of chemical energy. So the chemical energy present in the battery is converted into electrical energy. So these batteries cannot be recharged. So as long as active species are present in this type of batteries, we can withdraw the electrical energy. So batteries are non-rechargeable. These primary batteries are non-rechargeable. The cell reactions in this primary batteries are irreversible. The cell reactions in these primary batteries are irreversible. Example, your zinc air battery, zinc manganese oxide battery, zinc oxide battery. So all these are example for your primary battery. What do you mean by secondary battery? So all rechargeable batteries are secondary batteries. All rechargeable batteries are secondary batteries. So here the cell reactions are reversible. So during when you are using a battery, it acts as a galvanic cell. When you are charging a battery, it acts as a electrolytic cell. So these batteries are recharged by passing electric current, right? So you know this very well. So the example here is your lithium ion battery, lead acid battery, etc. So during discharge process, what happens during discharge, that is when you are using the battery acts as a galvanic cell. During charging process, the battery acts as a electrolytic cell. So we'll discuss in detail the construction working of few secondary batteries. So let us see the differences between the primary and secondary batteries. So primary batteries are cells which cannot be recharged or reused. So secondary batteries are the cells which can be reused again and again. So in primary batteries, the reactions are irreversible, whereas in secondary batteries, the batteries or the cells are reactions are reversible. Your primary batteries can be recharged, whereas your secondary batteries cannot be recharged. So primary batteries are used in the portable devices. They can produce energy or current immediately, whereas your secondary batteries should be charged before use. So this self discharge, that is what you mean by self discharge. So the cycle life, there is no cycle for life for your primary batteries, but there is a cycle life for your secondary batteries. Cycle life means number of times battery can be charged and recharged, that is called as cycle life. Okay, next. So examples for your primary batteries as we discussed is zinc carbon used in flashlights, toys, which use and throw batteries, used in radios, recorders. You have different types of primary batteries. So alkaline batteries, lithium batteries, silver, mercury oxide batteries. So all these batteries so are primary batteries. So used in hearing aids. So the deaf people will say it will be used hearing aids. That is also a primary battery used in calculators, watches, photo flash. So all these are primary batteries. So example for your secondary batteries. So nickel cadmium, nickel metal hydride, lead acid, lithium ion, all these are secondary batteries. So reserve battery. So here in reserve battery, usually a key component is separated from rest of the battery. Usually electrolyte is the key component of the which will be isolated. When a key component is attached, so if this is the battery, the electrolyte will be detached. When the key component is attached, a battery can be used. So such type of batteries have long shelf life. So what do you mean by long shelf life? Shelf life, what do you mean by shelf life? So if this is a battery, so when you manufactured the battery, so the output of the battery is 1.5 volt. So even after 1 year, the output should be 1.5 volt. After 5 years, it is 1.5 volt. 5 years, 1 day, the output is 1.49 volts. Then the shelf life is 5 years. So if for some other battery, 10 years it is 1.5 volts. 10.1 day, what will happen? It is 10.49 volts. Then the shelf life is 10 years. That is shelf life. So for how long a battery can retain the charge within itself without discharging is called as shelf life of the battery. So example, zinc silver oxide battery, magnesium silver chloride battery, etc. So these are used in sea beacons, mainly in meteorology and defense fields. So you have lithium ferrous oxide batteries which are used in thermally activated battery which is used in missiles especially. So these reserve batteries are exclusively used for military applications rather than household purpose. So whenever you want, you can attach. Whenever you don't want, you can detach the battery. So there's a small video. I'll just play. You can see.
Move around it. Here's how it works. With the circuit off, electrons in material A are stuck in their high-energy, high-stress atoms. Out of reach and on the other side of this electron barrier are material B atoms, which would offer an easy, cushy, low-energy level position. Let's turn the circuit on. Now you've offered electrons a path to happiness. Since they can't go any other way, they begin flowing through the circuit to material B. Back at material A, the atoms are losing electrons, because that's where the electrons are coming from, and they begin turning into positively charged ions. As we mentioned before, ions always want to be neutral, so these guys need to find a negative charge. So they go to where the negative charges are, in material B, where all the electrons are going. You'd think that these ions would just meet up with their lost electrons and become neutral atoms again. But unfortunately, the electrons are way happier where they are now. So the ions have no choice but to kind of mingle with the atoms of material B. So what we've got is kind of a mishmash with B atoms mingled with A ions. As the battery discharges, electrons and ions are making their way from A to B. When you can't fit any more material A ions into material B, the battery is fully discharged. To recharge the battery, you just do things in reverse. Instead of a circuit, you're putting an energy that forces the electrons back into material A. The ions then leave material B and rejoin their lost electrons.
The battery will act as a electrolytic
ready
cell.
to discharge again.
Thank you. We'll discuss the construction and working of nickel metal battery in our next discussion. Thank you.